In today's class, we'll continue with few more problems on conditional probability.
Cards numbered 1 to 10 are placed in a box. So in a box, we have cards from the numbers 1 to 10 mixed up thoroughly, and then one card is drawn randomly. Then one card is taken out randomly. If it is known that the number on the card drawn is more than 3, if it is known that the number drawn on one of the cards is more than 3, what is the probability that it is an even number? So there are in a box 10 cards placed, 1 to 10. There are two events what they are defining. The first event they are saying that if it is known that the number on the drawn card is more than 3. The first condition they are giving that the number what you are taking out in the card is more than 3. You pull out a card, it will be more than 3. What are the cases? That is one of the events. What is the probability that it is an even number? The other event is nothing, but it is an even number. So I have to find the probability of it is an even number. So this event E, I consider the probability of even number as to be found. When we know that the number on the card, the drawn card is more than 3. More than 3, I take it as an F event. So here we have 10 cards numbered 1 to 10 are placed in a box. So the sample space is written by this random experiment where I have 10 cards placed in a box. So S is the sample space. What is it? 1, 2, 3, up to 10 numbers I consider because 10 cards are there. 10 cards numbered 1 to 10. So box in which the cards are placed is the random experiment. From that I write down the sample space. There are 10 cards from 1 to 10. So S. Then E is the event what I am taking. What is the probability that it is an even number? It is an even number is the event E what I consider. I have to find the probability of it. So what are the possible cases? When I take out a card from this 10 cards, what are the cases I can get it as an even number? What are the even numbers in this? 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10. These are the possible 5 even numbers I can get back when event E is occurred. Event E is what is the probability that it is an even number? Out of 10, these are the cases. If it is known that the number on the card drawn, given that the other condition, what is the F condition? The card drawn is more than 3. So event F will be card is more than 3. So more than 3 when I take, what are the possible cases I get back? More than 3 means, what are the cases I get back? That is the event which is already occurred. So what are the possible cases I can take? More than 3 means I can start from 4, 5, 6, 7, 8, 9 and 10. So event F, if it is known that the number on the drawn card is more than 3, card is more than 3 means these are the possible cases I can. I got the sample space from the experiment where 10 cards are placed in the box 1 to 10. Then I have to find the probability, it is an even number. So this event E I have to find. For that event E, it is an even number means the only possible cases are these 5 are the even numbers from 1 to 10 for event E. What is the given condition? It is known that there is one event which is occurred. What is that event? Number of the drawn card is more than 3. More than 3 I have to take out. Event F card is more than 3 number. For event F, what are the cases? 4, 5, 6, 7, 8. Now I have to find conditional probability of even number. What is even number? Event F. Given that F is occurred, known that the number drawn on the card is more than 3. I have to find out the conditional probability of event E given that F is occurred. Now I have all the conditions. What else is required to find? I have to find out this one. This is unknown. Now, if I have to find this, the first thing what I have to consider is the number of elements in sample space, How many elements are there in the sample space? 10. Then number of elements in event E. Event E is when it is an even number. There are 5 number of elements. Event F, how many are there? Event F, it is the card drawn is more than card drawn. Card drawn is more than 3. What are the cases? 4, 5, 6, 7, 8, 9, 10. So can I say how many conditions are there here? 7 conditions. 3 cards are left out, remaining 7. With this, I also have to find E intersection. Let me see what are the common elements. E intersection. E intersection at I 2, I don't have 4, 6, 8, 10. So 4, 6, 8, 10. These are the common elements in these two events. E and F, when I consider the common elements in these two events are 4, 6, 8, 10. These are the only possibilities. 2 is not there in F, so I cannot consider. Once I know E intersection F, can I find the number of elements in E intersection F? How many elements are there in E intersection F? 4. So I found the number of elements in sample space, event E, event F, and number of elements in E intersection F. What I have to find conditional probability. Let me use the formula. Conditional probability of event E when event F is occurred is given by probability of E intersection F divided by which event is occurred F. Probability of E intersection F when event F is occurred, that is probability. How to find probability of anything? It is number of favorable outcomes divided by total number of outcomes. So number of favorable outcomes of E intersection F divided by total outcome is 100. Now we are taking probability for the numerator. What is the numerator? E intersection. Number of favorable outcomes of E intersection F divided by total number of outcomes is that. Whole divided by probability of F. Number of favorable outcomes of F divided by number of elements in the sample space. So I have defined the probability as number of favorable outcomes divided by total number. Substitute the value. What is the number of elements in E intersection F? 4. Divided by number of elements in sample space 10. So number of elements in E intersection F is 4. Number of elements in sample space is 10. Then number of elements in F. What is number of elements in F? It is 7. By number of elements in sample space is 10. 10 is common, I can cancel that. What will be left out? 4 by 7. So probability of event E when event F is occurred is 4 by 7. Probability of event E when event F is occurred is nothing but 4 by 7. That is what we found. So probability of event E when F is occurred. What was event E? With an even number. Given that when the card drawn is more than 3 is nothing but the solution of that is 4 by 7. The next problem, a die is thrown 3 times. So we consider a die, that is the random experiment, and it is thrown 3 times. Event E, 4 appears on the third toss. On the third die, the 4 appears. Event F, 6 and 5 appears respectively on the first two tosses. On the first turn and the second one, 6 and 5 appears. Find conditional probability of event E when given that event F is occurred. Then we define both the events. Event E is when 4 appears on the third path. Event F is 6 and 5 appears on the first two tosses. Let me see how to rearrange this. Now here, what is the random experiment I have? Random experiment is a die is thrown 3 times. So if I consider a die, I have the 6 faces on it from 1 to 6. But it is thrown 3 times, so the sample space I can write it as 6 cube. In a die, there are 6 faces and it is thrown 3 times 6 cube, that is nothing but 260. I'll not list all the elements of 216 cannot be listed in the sample space. So in general, when it is 6 spaces, how many times it is thrown? 3 times. So 6 cube, 260. But when I come to the events, let me define it. When I take the first event E, what does it say? 4 appears on the third toss. On the third coin, I should get back 4. What are the possibilities? Let me see. I consider the first one where I have 1, 1, 4. On the first two die, I'll have 1, 1. And the next third one, 4. Because even E says that 4 should appear on the third one. So third one, I'll keep it 4. Whereas the other two, I have to keep changing. So first one is 1 and second one is also 1. In the next condition, I consider first one is 1, second one is 2, but third one remains 4 because even E requires 4. Then the next one, 1, 3, 4. Then 1, 4, 4. 1, 4, 5. Sorry, 5, 4. 1, 5, 4. And 1, 6, 4. On all the 6 cases, you can see that I have 4 in the last one, and in the first die, I have taken 1 as the condition. And the third one, even E itself is given that 4 should appear on the third toss. 4 I retain the third one. The second one I kept changing 1, 2, 3, 4, 5, 6. Now I take the next condition. On the first one, I'll start with 2, but I will retain 4 in the third one. First one 2, third one 4 I retain, and go on changing the values of the second one. Second die will be 1, in this 2, then first one is 2, second one I will put 3, but 4 should remain in the third one. Then 2, 4, 4. First one again 2, last one is 4 because that is the condition of the condition. And I will 2, 6, and 4. Like this, I can write down for the next one 3, 1, 4 up to 3, 6, 4. The next one will be 4, 1, 4 up to what is the value? 4, 6, 4. Then the last one 5, 1, 4 5, 6, 4. Then next one will be again 6, 1, 4 6, 1, 2, 4 6, 3, 4 6, 4, 4 6, 5, 4 6, 6, 4. So these are the possible cases what I get back when I consider the event E. What is event E? When 4 appears on the third toss. In each of the cases, you can see that the 4 is in the third toss what I have considered. In the third toss, I have 4. And whereas the other two die when I consider. One case I considered it as 1 to 1. Then in the first die I considered 2, then 3, 4, 5. And I kept on changing in the second die 1 to 6 on the cases. These are the possible cases. What are the total cases I get back? Number of elements or the number of event what is occurred in event E. I have 6 for the first die is 1. Again similarly up to 6, that is I can say 6, 6 are 36 cases I have here. The first line I have 6, again the next one 6, again 6. There are 6 times it is. So 6, 6 are 36. So number of elements in E is nothing but 36. So the number of elements in E I take it as 36. Then F I have to consider. What is F? The next event what is defined? What is the next event defined? 6 and 5 appears respectively on the first two tosses. 6 and 5 should appear on the first two tosses. So 6 in the first die, 5 in the second die. Whereas the third die can go on changing. What are the possible cases? 6, 5, 1. 6 in the first one, 5 in the second one. 6, 5, 2. 6, 5, 3. 6, 5, 4. 6, 5, 5. 6, 5, 6. Can I say these are the only possible what I get back? 6 and 5 I cannot change. It should appear respectively on the first two tosses. 6 is on the first toss and 5 is in the second. So that I keep it same for all of them. Only third I can keep changing. What are the possible changes I can do? 1, 2, 3, 4, 5, 6. Because it has a die has 6 spaces, 6 possible changes. So this is the number of elements in F is nothing but 6. So I found the sample space, that is the random experiment was a die is thrown 3 times. So 6 cube 260. Event E was 4 appears on the third toss. On the third toss, I printed 4 and wrote down all the possible cases. How did I write? For the first die, I kept it as 1 throughout, and 4 is the condition on the third die. That cannot be changed. Only the second one, I kept changing all the 6 phases. 1, 2, 3, 4, 5, up to 6. Then I put in the first die, second one, and third die, I retained 4 as it is. Second die only was possible to change. I started with 1 and went to 6 because 6 phases. Similarly, for the first die, I took 3, retained the third die as 4 because that is the event. And 1 to 6, I changed on the second. Similarly, for 4, 5, and 6. Based on this, in event E, the number of elements is 30. Then event F was defined as 6 and 5 appears on the first 2 tosses. On the first 2, I have 6 and 5. So based on that, I get back 6. So 6 and 5 I retained as it is. Only on the third die I kept on changing. What are the possible changes I can do? All the 6 phases of the die, that is 1 to 6, I kept changing on the third. So the number of elements in event F is 6. With this, I have to find E intersection of. I have to check whether I have any common elements. So common elements when I check, only possible cases on first die when I have 6. First die is 6, I cannot take the first two, second, third, fourth, fifth row at all because on the first die, no, it is not 6. Only the possible is the last one. On the first die, I have 6. Only with that I can compare. And the second die should also have 5. So which is that possible case? 5 and 4. So here 6, 5, 4 is the only common element what I can choose. Whereas the remaining I don't have any common elements at all. First die should be 6. That is the last line. And second die should be 5 only. So 6 and 5. In the first event, the third toss should be 4. So that is the only common element what I can consider. This is the only possible common element what I can consider. So 6, 5, 4. Then number of elements in E intersection F is nothing but 1. Only the possible cases 6, 5, 4, 6, 5, 4. This is the only common element when I take E intersection F. E intersection F has 6, 5, 4. So when I consider 6, 5, 4, it is nothing but the number of elements in E intersection F is 1. Now, I have to find the conditional probability. Now, let me try to find the conditional probability. What I have obtained, conditional probability of event B given that event F is occurring. I have to find out probability of event E when event F is occurring. So I use that. What is the definition? Probability of E intersection F divided by probability of which event is occurred. Probability of E intersection F when event F is occurred. Now, what is the definition of it? The definition says probability of E intersection F is number of elements of E intersection F divided by number of elements in the sample space. Whole divided by number of elements in event F divided by number of elements in the sample space. Number of favorable outcomes divided by total number of outcomes. So probability of E intersection F is number of elements in E intersection F divided by number of elements in the sample space. Whole divided by number of elements in F divided by number of elements in the sample space. I can say that number of elements in the sample space will remain the same, 216 I can cancel. Number of elements in E intersection F divided by number of elements in F. What is the number of elements in E intersection F? It is 1. Divided by number of elements in F is nothing but 6. 1 by 6. So number of elements in E intersection F is nothing but 1 and number of elements in F is nothing but 6. So probability of event E, that is 4 appears on the third toss, given that event F 6 and 5 appear respectively on the first two tosses, the conditional probability of E when event F is occurred is 1 by 6. The next problem. Mother, father and son line up at random for a family picture. So, take a photo. The three person what we are considering from the family are father, mother and son. In that, event E is son on one end. On a photo, the son will be on one of the F, father in the middle. So, in the photo, father should be in the middle, that is F condition. Find conditional probability of event E when event F is occurred. Let us see how to do it. Now, the first one, event E when I take, sun should be on one of the end. So, either on the left or to the right. When I take sun, I denote sun by S, father by F, and mother by M. So in a family, they are going to take a photo with three people included. I denote M for the mother, F for the father, and S for the son. So I'm going to use the three alphabets M, F, and S, where M stands for mother, F for father, and S for son. So F, son should be on one of the headings. So I take the first one, then father, or I can also have son as it is on the left side, mother, then father. So one of the end I have considered. I have considered to the left. So son is on the left. One case father will be in the middle and mother at the right. The other case mother in the middle, father at the right. Then the next possible case is to the right I can have son. Again mother first and then father in the middle with son at the other one. The next case what I can have is father first, then mother, then again son to the right. So I maintain sun at the left side at one end once and sun to the right. Interchanging father and mother. Once father was in the middle and mother was in the middle. In this case again father is in the middle, mother is in the middle. So these are the four possible cases when I take sun on one of them. Then father in the middle when I take. Father in the middle is the only possibility is son and mother again interchange. First I have son, then father, then mother. Again father should be in the middle. Mother and son can get interchange. So these are the two possible cases what I can have. So written event E, event F. Then E intersection F is, let me see the common. Do I have common element? Yes. S, F, M, son, father, mother, that condition is there. N, F, S, again this condition is there. So E intersection F has two possible cases. So here the sample space, the random experiment is in a family. They are taking a photo which includes three people. That is number of elements in the sample space S hypothesis. Then event E is son on one, father in the middle. Then E intersection. What is asked to find conditional probability of event E given that event F is occurred. Let me see how to rearrange this. Now, conditional probability of event E when event F is occurred is given by probability of E intersection F divided by probability of which event is occurred F. Probability of E intersection F given that probability of F is occurred. Now, probability of E intersection F is number of favorable outcomes of E intersection F divided by number of elements in the sample space. That is the total number of outcomes. Divided by probability of F can be written as number of favorable outcomes of F divided by number of elements in the sample space. So number of favorable outcomes divided by total outcomes is the definition of the probability what I have used. Now, number of elements in the sample space I cancel. Number of elements of E intersection F divided by number of elements of That I can easily obtain. What is the number of elements in F here? The number of elements in F is 2. Number of elements in E is 4. The number of elements in this case, E I write down here. The number of elements in each one if I consider. Number of elements in E is nothing but there are four possible cases. Number of elements in F we have possibilities is 2. Number of elements in E intersection F is nothing but again it is 2. So I've already found the number of elements in E, F and E intersection F. I'll try to substitute. Number of elements in E intersection F is 2 divided by number of elements in F is 2. 2 and 2 get cancelled. 1. So conditional probability of event E when event F is occurred is given by 1. Conditional probability of event E given that F is occurred is nothing but 1 in this case. Next one. If probability of A is R, probability of B is 0, then find conditional probability of event A given that event B is occurred. They've asked you to find the conditional probability of event A when event B is occurred. Now, conditional probability of event A when event B is occurred is given as probability of A intersection B divided by probability of B. Because probability of B is the event occurred. But what is given in the data? Given in the data, probability of B is equal to 0. This does not define, it cannot be defined under this condition. I cannot define conditional probability of A when event B is occurred if I have the condition probability of B is equal to 0. This is not defined. I cannot define this. This is undefined and not defined. The definition of conditional probability was if I take it as E and F because A and B is used. Definition of conditional probability of E when event F is occurred was probability of E intersection F divided by which event was occurred? Event E. Event F is occurred, so probability of E intersection F divided by probability of F, where probability of F is not equal to 0. It cannot be equal to 0. This is the definition what we define. So I cannot consider this. Probability of B is equal to 0. I cannot consider. In this case, it is not defined or undefined. I cannot define this. This is not defined. Because the definition says probability of F, what I have in the denominator, cannot be equal to 0. Next one, probability of event is 6 by 13, probability of event F is 5 by 13, and probability of E union F is 7 by 13. Find conditional probability of E given that F is occurred. Let us see how to rearrange. Now, if I want conditional probability, the condition is probability of E intersection. I don't have probability of E intersection. From the given data, I will try to find out probability of E intersection F using the formula probability of E union F. Probability of E union F is already given. I use this formula to try to get back probability of E intersection. Probability of E union F is probability of E plus probability of F minus probability of E intersection F. To find the conditional probability, I need probability of E intersection. That is not given in the data. I have formula for probability of E union F. I try to use that where I can take probability of E intersection. What is probability of E union F? 7 by 13 is equal to probability of E is 6 by 13. Probability of F is 5 by 13 minus probability of E intersection. If I shift that, probability of E intersection is 6 by 13 plus 5 by 13 minus I take the 7 by 13. If I try to rearrange this, probability of E intersection 30 is the LCM. 6 plus 5 minus 7. So 6 plus 5 will give me 11. 11 minus 7 is 4 by 30. So I'll try to rearrange it is 4 by 30. Now I'll find out conditional probability of event E when event F is occurred. Since in the given data I had only probability of E, F, union, using the formula of probability of E union F, I try to find probability of E intersection F. Once I obtain probability of E intersection F, now I will use the conditional probability. What is it? Probability of E intersection F divided by probability of F, because that is the event what is occurred, which is already given. What is the probability of E intersection F? 4 by 4. Divided by F is 5 by 2. So 13 and 13 I can cancel. So this is 5 by 2. The denominators are same, I can cancel 4 by 2. That is the value of conditional probability of event E when event F is. So these are few more problems what we have on conditional probability. In the next class, we will start with the next topic, that is multiplication.